Hey everyone, welcome back to my YouTube channel. Ever wondered why the same AI model gives brilliant answers in one app and completely wrong answers in another? It's not the AI, it's how the AI is optimized. In this video, I am going to break down three powerful techniques that decide whether your AI system succeeds or fails: prompt engineering, retrieval augmented generation or RAG, and fine tuning. You will learn what each one actually does, when to use which, and how companies combine them to build production ready AI systems. If you are a student, developer, or working professional trying to understand modern Gen AI beyond the hype, this video is for you. Let's dive in. Large language models like GPT are incredibly powerful, but they are not perfect out of the box. If you want to use them effectively in real world applications, especially in enterprises, we need to optimize how they work. That's where prompt engineering, retrieval augmented generation or RAG, and fine tuning comes in. These three techniques helps us improve accuracy, relevance and control when working with LLMs. At a high level, prompt engineering is the simplest approach. RAG connects the model to external knowledge and fine tuning actually retrains the model itself. They solve different problems, but in practice, they are often used together. Let's start by understanding why these techniques are important. Prompt engineering allows us to give models explicit instructions on how to behave. With clear and well structured prompts, we can shape model behavior precisely without investing in expensive training or complex retrieval systems. RAG is important because it plugs in an LLM into proprietary or real time data that the model otherwise cannot access. By adding internal documents, databases, or live information into the prompt, RAG enables the model to return much more accurate and context aware answers. Fine tuning is important when deep specialization is required. A fine tuned model typically outperforms its base model because it has been trained on domain specific data. This helps the model understand specialized terminology, workflows, and patterns much better. Now, let's look at each technique in detail. Prompt engineering. Prompt engineering is the process of designing effective prompts that guide a model toward the desired output without expanding its knowledge base or changing its internal parameters. The goal is simple: to make the model's output match the exact requirement of your use case. No amount of training or extra data can compensate for poor prompting. Prompt engineering works through iteration. You write a prompt, observe the output, refine the instructions, adjust the format or tone, and try again. With each iteration, you learn how the model responds and how to guide it more effectively. Good prompt engineering tells the model exactly what to do. It may include step by step instructions, output formats, examples, or constraints. Think of a machine learning model like an aspiring home cook who wants to make a great dinner. Prompt engineering is like a knowledgeable friend guiding them, suggesting what to cook, how to prepare it, and what mistakes to avoid. With better guidance, the final dish improves dramatically. Prompt engineering is best suited for content generation, creative tasks, open ended problems, fast prototyping, and low budget experimentation. Retrieval Augmented Generation RAG. RAG is a data architecture framework that connects an LLM to external data sources, often an organization's proprietary data stored in data lakehouses or document repositories. Instead of relying only on what the model learned during training, RAG injects relevant data into the prompt at runtime. Here's how RAG works. First, a user submits a query. Next, the system retrieves relevant information from internal or external knowledge base using semantic search. Then the retrieved data is integrated with the user's query and sent to the LLM. Finally, the model generates a response using both its training and the added context. Semantic search is a key part of RAG. Instead of matching keywords, vector databases search by meaning, allowing the system to understand user intent and retrieve the most relevant information. RAG system requires solid data engineering. Data pipelines must be built and maintained to connect knowledge sources with the LLM. Strong prompt engineering is still essential to ensure the right data is retrieved and used correctly. Returning to our cooking analogy, if the model is an amateur home cook, RAG is like giving them a cookbook for a specific cuisine. By combining basic cooking skills with expert recipes, the cook can now prepare accurate and authentic dishes. RAG is ideal for customer support chatbots, enterprise search, compliance systems, and any application where accuracy and up to date information are critical. Next, fine tuning. Fine tuning is the process of retraining a pre trained model on a smaller domain specific data set. This allows the model to adjust its parameter and embeddings to better fit a particular use case. Unlike prompt engineering or RAG, fine tuning actually changes how the model behaves internally. Fine tuning uses supervised learning, which means the data is labeled and structured. The model learns from examples and updates its weights accordingly. Imagine again the home cook analogy. Fine tuning is like enrolling the cook in a formal training course for a specific cuisine. After training, they don't just follow recipes, they understand the cuisine deeply. There are two main types of fine tuning. Full fine tuning updates all the model's parameters. It is powerful but expensive and compute intensive. Parameter efficient fine tuning or PEFT updates only the most relevant parameters. It delivers comparable performance improvements while using far fewer resources. Fine tuning is especially useful for highly specialized tasks, consistent output formats, sentiment analysis, and industry specific language. It also helps reduce bias and improve real world accuracy. Fine tuning should not be confused with continuous pre training. Continuous pre training uses unlabeled data to expand general knowledge, while fine tuning uses labeled data to sharpen performance on specific tasks. Quick reminder, if this is helping you understand Gen AI clearly, hit like and subscribe. It really helps the channel. Thank you. Bringing it all together, each technique serves a different purpose. Prompt engineering controls model behavior, RAG adds real time and proprietary knowledge, fine tuning builds deep domain expertise. In real world systems, the best results often come from combining all three. If your task is creative, prompt engineering may be enough. If accuracy and freshness matter, RAG is the right choice. If deep specialization is required, fine tuning delivers the best results. Understanding these techniques empowers you to design smarter, more reliable AI systems and unlock the full potential of large language models. So now you know prompt engineering controls behavior, RAG adds real time knowledge, and fine tuning builds deep expertise. None of these are competitors. The best AI system uses all three together. If you are serious about building or teaching AI systems, understanding this stack is non negotiable. In the next videos, we'll go deeper into real world RAG architectures, prompt frameworks, and fine tuning strategies. Subscribe for more practical AI concepts explained simply, and I'll see you in the next one. Bye bye.